So today's webinar will be about model monitoring with SageMaker. So clients often face the following problem. Once my ML solution is deployed to a production level environment, how do I know if my ML solution is working? The solution, model monitoring. What is model monitoring? Model monitoring is the process of monitoring your model's performance in a production level environment. And this means capturing key performance indicators that can tell you when a model is doing well and when it's doing not. So why do I need model monitoring? When deploying machine learning models to production, there are several factors that can change over time. The model may start to drift from the performance you're expecting when you deployed it. The data being fed into your model may change over time, depending on your use case. The second a model is deployed to production, you already are going to need to get ready to retrain and redeploy it. So what is exactly model drift? Model drift is the decay of a model's performance over time once it's deployed to production. Model drift may be called data drift if the data distribution that is being fed into your ML model changes over time. Or bias drift if a type of model drift that occurs if the data that you use to train your model is different compared to the data your model sees in production. And feature attribution drift is the drift of the features being used in your ML model and their attribution scores, which can change over time depending on the data that's being fed in. But at the core, model drift is caused by changes in your data. And now I'll hand us over to Prachi to give us a deep dive into solving these specific model drift problems using AWS SageMaker.
Thanks, Ray. So let's go to the next slide. Okay, now Ray has already covered why we need the model monitoring. Basically, as he mentioned, model monitoring is monitoring the model in production. We can keep on, if you don't want to monitor the model, another way of doing it is keep on retraining the model, but continuous retraining does not solve issues, and as well as it needs a lot of resources. So retraining only when necessary is what you should aim for, and that's where the model monitor is going to help you. If you can go to the next slide. As mentioned already, there are these types of model monitoring: the data quality, the model quality, the bias and explainability. Basically, the data quality has a lot of, for example, a lot of statistics mentioned here, mean and sum and standard deviation, etc., where, and I'm going to go into a little bit more detail about that, but those are the criteria on which the data will be examined. The other one is the model quality, where your model is predicting something, and how does that prediction compare with the actual reality? And that's where we are looking at the model quality. And of course, the RMSE or the F1 score, etc., are the metrics used for the accuracy in prediction. The other one is bias. Ray already mentioned about it. And then the model explainability. I should mention that for model bias and model explainability, the SageMaker Clarify is a tool that we use typically, because Clarify is used for model explainability, and it wonderfully integrates with the model monitoring service. So you can basically use the SageMaker model monitor and further use Clarify to talk about the bias and explainability. In today's presentation, I'm majorly going to focus on the data quality and the model quality. And let's do that. If you can go to the next slide. Okay, so this is typically the life cycle of model monitoring. What we are going to do is we need a model that is deployed, of course, which is deployed in production, and we need to enable the data capture. Now, this data capture is in two ways. One is you're capturing the data which is sent to the model, and there is a specific way you enable in the SageMaker API where you enable the data capture. And the other one is and we call it ground truth data. I will be referring it to it as ground truth. It does not mean SageMaker ground truth. It's just the ground truth data. So the other data that you're going to capture is the ground truth labels. And this data is something which is needed for the model quality monitoring. And that is the data that the customer, the user will have to provide. And I'll explain a little bit more about that. The data quality monitoring does not need the ground truth labels. The model quality monitoring will need the ground truth labels. But anyway, basically you have a model which is deployed. Then you collect the ground truth based on which quality that you're that you're mentioning. Then you generate a baseline. Now, for data quality as well as model quality, establishing a baseline of statistics and mentioning the constraints is an important step in the model monitoring, where you establish something against which the quality of the model will be compared so that the data drift or the accuracy drift can be justified. Can be calculated. And then you schedule the model monitoring jobs, which will detect the data quality drift, the model accuracy, etc. And those findings are made available in S3, as well as could be visualized in SageMaker Studio. They're also sent to CloudWatch, on which further action, depending on the CloudWatch alerts, can be taken. If you can go to the next slide. Okay, so let's look at monitoring data quality. Next slide, please. So we looked at a couple of statistical properties for the independent variables in the data that were mentioned in the earlier slide. They can be mean, mode, etc. What you're going to do is, looking at the ground truth data, when you're establishing a baseline, you are going to have some business rules. The business rules could be automatically suggested. They could be also edited and updated by you. And then once those business rules are set, basically a baseline will be established looking at your looking at your initial ground truth data. Again, I'm not looking at the predicted variable, I'm just looking at the data. Now, the best practices for this type of baseline generation and further data quality is that the S3 in which the data is captured, the initial data as well as later on the data which is captured by the model during model monitoring, should be in the same region, of course, as the model monitoring. And both for model quality monitor and data quality monitor, the instance utilization should be something that you should watch for. You should not have the instance utilization above 70%, because many times SageMaker tends to reduce the data capture if the instance utilization is above 70. So those are the, and then of course the model monitoring effectiveness kind of goes down. So this is where you should, these are some of the best practices. If you can go to the next slide, when we look at the, this is the diagram that depicts the architecture of the data capture. You have the training data. Using the training data and SageMaker training job, there is a model that is generated, trained, and it is enabled as a SageMaker endpoint. Now, you also have a baseline processing job, which, looking at your business rules, it has created a baseline and mentioned various statistics, suggested a lot of constraints. There is a small group of users which is mentioned here, which shows that you can look at the constraints and you can update the constraints, the business rules, so to say. Once the endpoint is deployed, there are requests for specific data, production data, and predictions are made. And there is a modeling job, there is a monitoring job for the model monitor, which is scheduled, which is going to save all the results and statistics and violations in S3. So now when I'm talking about violations, those violations are of course going to generate CloudWatch alerts and metrics. And depending on the CloudWatch alert, you can decide to take action. Maybe if it is a CloudWatch alert which says, say, for example, the data quality prediction, the data quality monitor shows me that the data drift is more than 30%. Maybe that's the time you decide to retrain the model. And that's where, looking at the CloudWatch alert, you can just trigger a job that is going to retrain the model. So this is about the data quality monitoring workflow. If you can go to the next slide. Some of the violation check types are mentioned here. So say, for example, if the type of the data that is getting sent to the model is the same on which the model was originally trained, are there any missing columns? Are there any extra columns? Are there same categories? Are there more than expected number of nulls in the data? All of this can happen when suddenly the data that is sent into the production changes. Typical example given is during the pandemic, we suddenly shifted the interactions to remote from the in-person interactions. So the data that was sent to the models was suddenly and radically shifted. So all these violations are going to kind of document the data quality that is coming in for you. And I talked about the CloudWatch alerts. These violations will show up in the alerts and you can act on them once they show up in CloudWatch. If you can go to the next slide. Next is the model monitor model quality, which is going to need your target variables. And I'll tell you how, if you can go to the next slide. This is about the model accuracy. So it's not just the data that is going to shift, it is the accuracy as well. So sometimes the data does not shift very drastically, but the business rules are such that the accuracy of the model in predicting the target variable keeps on going below the established thresholds. For this, what you want to do is you want to capture the labeling data as well. Now, the data capture that is enabled by SageMaker is going to capture the data that the model predicted. But there also needs to be a way for the model monitor to get an access to the predicted variables of the model. And typically this is done doing human in the loop, or there are multiple ways of doing that, where in the production data, doing some sampling, you are predicting the variables and basically SageMaker, the target variables, and basically SageMaker is going to combine those human predicted target variables over the period of time with the target variables predicted by SageMaker model and execute a merge job. And then depending on the results of the merge, compare the feature statistics. This is more elaborated in the workflow on the next slide, if we can go there. Sorry, there's one more. So these are typically the quality metrics that it is compared against. And of course, depending on whether it is multi-class classification or binary classification or regression models, those are the quality metrics that SageMaker model monitoring is going to work off of. If you can go to the next slide. Okay, so here, as depicted in the diagram, basically the initial part, the right-hand side, left-hand side of part of the diagram looks the same for data quality and model quality. You're basically establishing a baseline. And then what is happening is once the labels are provided, the ground truth interface on the rightmost side, that is the inference variables which are shared by human in the loop. And the inference inputs are shared also by the SageMaker. Now, in this case, it is a batch transform, but it could be a real-time endpoint. It could be a batch transform as well. Those two variables are merged, and the merged data is also made available to you. And a monitoring job is going to monitor results of the merged job. And then the workflow kind of goes similar the way the data quality work goes, where you can look at the thresholds and the statistics, and a violation report is generated in CloudWatch, and you can take action on that. Essentially, this is like looking at the overall model quality and not just the data quality. If you can go to the next slide, I think that's the last one. Okay, yeah. So feel free to stop, feel free to ask questions on anything related to the SageMaker model monitoring, and I can answer those.
Great, thank you, Prachi. I'll now be showing us how we used some of the tools that Prachi had described to solve a particular client's ML problems. So Security came to us with a deployed machine learning model in production that needed to be constantly monitored for performance to ensure that their product was working consistently for all their clients. The metrics that they needed to monitor were custom and needed to be monitored every hour. SecureDode's application takes in as input CloudFront logs from its clients and uses an ML algorithm to determine whether activity on one of their client sites is malicious or not. And SecureToad's system is adjustable and also allows their clients to adjust the sensitivity of their system by setting thresholds to auto blacklist malicious IP addresses. So our client needed a way to monitor their model in production and to monitor it every hour with a custom metric for this particular algorithm. This is the solution that we created for them. SecureToad's model needs to perform well across a wide range of clients. So in order to do this, we'll need a model that is monitored across the performance on multiple clients of the same algorithm. So the model that they have essentially produces scores, which can be used to generate a distribution of scores on site activity, similar to the curve that you see on the right. If this distribution of scores drifts and takes a different form over time, then the model may need to be retrained. Then the question became, what metric do we need to use to capture this specific kind of drift? And was this something that we needed a custom script for? So we chose to use a metric called Jensen-Shannon divergence, which measures the difference between two distributions on a scale from 0 to 1. The closer the number is to 1, the more dissimilar the distributions are. The closer the number is to 0, the more similar they are. The score is 0, they are completely the same. If it's 1, they're completely different. This gave us a single metric that we could set up a monitor for. By having a single value like this, that helps describe the model's performance across multiple clients and flagged activity, we could easily set a threshold to be used to determine when to alert SecureToad's development team that they need to retrain their model. So we built a Python script to capture this metric and prepared it to be deployed as a custom model monitor metric. To deploy a custom model monitor metric to AWS, we developed a GitHub Actions workflow and pipeline to create a Docker container image with that script on it, and upload it to AWS ECR, Elastic Container Registry repository, to then be referenced by a model monitor job when we need to make one. So this pipeline not only builds and deploys a new image if the code to the Docker file or the custom metric script in Python is modified, but this also automates what would otherwise be a very intensive manual process. So we can now easily build and deploy custom model monitor scripts, giving us the flexibility with the metrics we can return from the monitor. So now that we have the model monitor script ready, we need to factor it in to our deployment pipeline. So we built out, as part of the ML training pipeline, a step for SageMaker model monitor creation and automated cleanup for old endpoints and resources. So I'll guide us through each step of the pipeline, starting from the left, and explain their features and what they do to add to the SecureToad product. So we need continuous monitoring and training of SecureToad's algorithms to have it perform up to the standard for their clients. So in order to facilitate that more seamlessly, we have a step function with all the necessary components for training the algorithm, creating the model, deploying endpoints, and monitoring them. So the first step here generates a unique training job name based on their requirements. The next step creates a SageMaker training job based off of the name and SecureToad's custom algorithm. We send in hyperparameters at this step as well. So once the training job has been completed, a model version is created and stored. Then the endpoint configuration is made, which takes into consideration the instance size we're deploying it on, the name of the endpoint, and the data capture configuration, which is used by the model monitor. Once we have an endpoint configuration, the endpoint is deployed and can now be invoked by their production level site. So once the endpoint has been deployed, a SageMaker model monitor job will be attached to it via a Lambda function. So this takes the custom model monitor script that was deployed to ECR via our Docker pipeline and schedules the script to run every hour. So the model monitor takes data from the training data sets, S3 bucket, and some sampled inference data from production, and generates metrics. So the monitoring job is set to only execute if data has been sent through the deployed endpoint. So when the model monitor generates a model report JSON file, it's put into the model reports S3 bucket that we made for them. And an S3 event and notification is sent to a SQS queue for evaluation by a report processing Lambda. Basically, what this Lambda does is that it looks at the results of the report, any kind of significant violations, the results of the metrics, and then determines what action to take after that. For example, we can have a configuration to send an alert to the SNS topic to send a message to the development team to look at deploying another model or running more experiments. And then the final step of the step function cleans up any old endpoints and model monitors. It looks at all currently deployed endpoints and models and deletes any endpoints and models that are older than the last 5 that were deployed. So now with a model monitor, SecureToad can better ensure quality of its application services to their clients. And that's the solution we created for SecureToad. And with that, I'll hand us over to Nathan or Stacy to talk about our POC funding opportunity.
Sure, happy to do that. Hi, everybody. And thank you guys so much for walking us through that. Hopefully everybody had some great takeaways. And if you did, and you're thinking about how do I get started, and I may need to prove out this concept to my executive stakeholders before I get full funding approval, then AWS and Metaltoad have got some insights for you here. AWS offers proof of concept funding. If you partner with an aligned partner here, like Metaltoad, then we can go in and evaluate what you guys are trying to prove out. We can then work with Amazon to understand how this workload may impact your monthly Amazon Web Services costs. And based on that, you may have the opportunity to get up to 10% of 1 year annual reoccurring revenue that will be paid by Amazon to support this proof of concept. So it's a one-time capped out opportunity of up to $25,000. And it would be paid to the partner such as Metaltoad at the completion of the project. So anyway, if this is something that's interesting to you, or you'd like to learn more about how Amazon POC funding could potentially help you with a machine learning initiative, please reach out. We'd love to see how we can get you some free money.
Thank you, Stacy. We are running very low on time, but let's see how many questions we can get answered real quick. The first one we have here is, are there any best practices or tips for effectively using SageMaker Model Monitor in real-world machine learning projects? Prachi, can you answer that one for us?
Yes. So I already talked about the instance utilization and the S3 being in the same region, etc. Other than that, this is not necessary, but as a best practice, some simple things like keeping the variables in lowercase and using underscore, because all of this is going to go through SageMaker, through JSON and Parquet and sometimes Spark, because there are Spark jobs run behind the scenes in Model Monitor. So it kind of helps ease out the issues because of special characters, etc. So that's just one more practice. Then typically Model Monitor is hosted in a VPC. So having all the accesses ready, the VPC endpoints available, etc. All of those needs to be taken care as part of the best practices and tips.
Thank you very much.
Yeah.
And we are at time. If you want to stick around, we have a couple more we're going to try to get to right now. But if you can't, thank you for joining us. Next one, how does SageMaker Model Monitor capture and store the data required for monitoring and analysis? Ray, can you grab that one?
Yeah, I can grab that one. So when you're setting up a data capture configuration, you can define an S3 upload path. So a particular bucket or URI, basically a destination you want the data to go to when you're creating it. And then you can also set a sampling percentage. So you can sample a specific percentage of the data that is being fed through that specific endpoint. And then that's stored in S3 for you to use for evaluation.
Okay. Thank you. And last one here. What do model monitor scripts look like? Is it similar to writing a Lambda function? Are there standard parameters they expect? Right? Can you answer that one as well?
Yeah, I can answer that one. It's very similar to running a normal Python script, like a Jupyter notebook. But essentially, when you create the model monitor, you can set up environmental variables to be passed in that are accessible when the script runs. But it's very similar to what you'd expect in a Lambda function.
Great. Thank you very much. Those are all of our questions. I hope to see you all here next time when we do our next webinar.